Good day, students. You are welcome to basic science class. I want you to listen attentively and I want you to pick up your writing materials as we go through the course of this class. In the last class, we learned about simple machine. We started by defining what a machine is, and we talked about the definition of a simple machine. In the last class, we mentioned the 6 types of simple machines. Today, we want to look exclusively into these 6 types of simple machines. We want to see what a lever is. We want to see what the wheel and axle is. We want to see what the pulley is. We want to see what the wedge is. We want to see what the inclined plane is. And want to see what the screw is. In the last class, I briefly talked about the lever. I told you that the lever has 3 major components, which are the load, the effort, and the fulcrum. And I told you that the lever is classified into 3, and that's the first class lever, the second class lever, and the third class lever. Or we say the first order lever, the second order lever, and the third order lever. All right. I told you that in the first order lever, what you have is that the fulcrum is between the load and the effort. The fulcrum is between the load and the effort. What do you mean by the fulcrum? The fulcrum is the turning point. The fulcrum is the turning point or the pivot. All right. The load is the point of the resisting force. Yes, the load is the point of the resisting force, while the effort is the point where the force is applied. The effort is the point where the force is applied. So for the first order lever, you have examples like scissors and you have examples like hammer. You have examples like scissors and you have examples like hammer. And I told you in the last class that when you have your scissors, you can just put your hand, inside the 2 holes of the scissors, and then that is the point where you have your effort. Next, after the point that you have applied the effort, you will see that there is going to be what? There's going to be a fulcrum before you now have the load at the other hand. So you have an effort, you have a fulcrum, and you have a load. So that is for first class lever. For the second class lever, what you always have is the load that is between the fulcrum and the effort. You have the load between the fulcrum and the effort, and that's what you have in wheelbarrow. In your wheelbarrow, you have the load in between the handle of the wheelbarrow, and that is where you have the effort, because that's where you're going to apply the force in pushing the wheelbarrow. And then you have the fulcrum or the pivot, at the other hand. That's immediately after the load. So that's for second order lever. And another example of the second order lever is the bottle opener and the nut cracker. For the third order lever, you have the effort between the fulcrum and the load. You have the effort between the fulcrum and the load. And that's one. The example is the forearm. The forearm. Also in the last class, I told you that a very good example of the third order lever is the tongue. So you can hold the tongue in the middle. You have the fulcrum or the turning point or the pivot before the point where you hold or where you apply effort in pressing down the tongue. Then the tongue will be able to pick the object. Take for instance, you want to pick the test tube. You want to hold a test tube in the laboratory to identify maybe a cation or an anion. You want to place it in the Bunsen burner. You have to hold it with the help of the tongue, and you have to hold it in the middle. So you always have the effort. The effort applied is in the middle. The fulcrum or the pivot is at one end, and now the load, which is the test tube that you are using the tongue to hold, is at the other hand. That is the third order lever, and that is that for lever. Secondly, we're looking at wheel and axle. This wheel and axle is a simple machine that is used to lift heavy load from depths. The wheel and axle is used in lifting heavy load from depth. It consists of a large wheel on a small axle that turns in the same axis. Example of wheel and axle include bicycles, fan, wagon. You know, your wheel and axle is just a simple machine that you can use to draw out heavy load from depths. You can use it to create turning effects in bicycle. That's your wheel and axle. You can use it in carrying every object, from depths, you lift it to heights. For instance, there are some of us that we use the traditional well at home. We always have a wheel and axle. You have your bucket with which you want to draw water out of the well attached to a string or a thread, and that thread is now wound round a wheel. So by the time there is an axle, or there is an handle with which you turn the wheel. As you are turning the wheel, what happens is that the bucket of water down the well comes up. So that's a good example of wheel and axle. And the essence of all these things, I have told us that the essence of a simple machine is to reduce the amount of effort that we use in achieving our day-to-day work. Just to make sure that you put in a small effort and you achieve a big work. You achieve something big. That is the essence of using a machine, and to make it more convenient for you. So convenience is very important, and also reducing the stress and reducing the effort that you apply is also very important. Another example that we are considering today about the simple machine is the pulley. The pulley. A pulley consists of a wheel over which a pulled rope or chain runs to change the direction of the pull used for lifting a load. Combinations of two or more pulleys working together reduce the force needed to lift a load. Can you see that? We also have a pulley. A pulley is used in pulling or in lifting a heavy load, and you have a rope or chain attached to the pulley. And the pulley can also be a combination of two or more pulleys. Of course, that is to reduce the amount of effort that is actually used in moving the pulley. So you can have a combination of two or more pulley working together, reducing the force needed to lift a load. All right. The uses is that it is used in lifting and moving load in cranes. It is also used in lifts. That's elevators. It is used in lifts. That's in elevator. That's for a pulley now. Now, another example is the wedge. When you're talking about a wedge is a triangular shaped tool, and it is a portable inclined plane. Can you see that? It can be used to separate two objects or portions of an object, lift up an object, or hold an object in place. A wedge can be used to split objects open, especially wood. The essence of having a wedge is to split objects open, especially wood. There are two objects or a portion of an object that needs to be separated. You can easily make use of a wedge. And the wedge is always triangular in shape. It is a triangular shaped tool which is portable. So it is used to separate two objects or portions of an object. And it is used in lifting up objects. It can also be used to hold an object in place. So while you are walking, the wedge can just be there, and the two objects are suspended, they are separated, and then you can do your work while the wedge is still between them. All right. We also have the screw. A screw is a type of fastener. A fastener characterized by a helical ridge known as thread. Most screw rotate in a clockwise manner, but few rotate in anti-clockwise manner. Your screw is simply used in drilling into hard surfaces. The essence of the screw is to drill. It allows you to drill into hard surfaces. So what happens in screw is that your screw is more or less like a fastener. You fasten it, you drive it, you fasten it. Take for instance, you have a log of wood, or you have a simple wood. You fasten it, or you drive it into the wood, and it has a helical ridge. The excess of the helical ridge is to allow the swift movement, to allow the easy movement or the easy fastening of the screw into the log of into the wood, you know. And what we are actually using it to do is that we are using it to bore hole. We are using it to bore hole or to create hole into hard surfaces. You can use a screw or even on metals. You can use screw on block. Yes, you can use screw on wood also. And lastly, we are going to talk about the inclined plane. Inclined plane. An inclined plane is a flat supporting surface tilted at an angle. A flat supporting surface tilted at an angle with one end higher than the other, used as an aid for raising or lowering a load. The inclined plane is often used to lift a load over a vertical obstacle. Your inclined plane helps man to overcome friction in doing work. Take for instance, you have a bar or a drum of water or a drum of alcohol, whatever it is, that is so heavy and you can't just move it yourself. Possibly you want to move it from a car or from a lorry down, you want to offload it, to the ground or to the floor. What you have to use is an inclined plane. The inclined plane is flat ordinarily, but now it has to be tilted at an angle. So the tilting actually reduces the friction. The opposition to the flow or to the movement of the load is being reduced because it has been tilted. All right. So your inclined plane helps you in lifting that load over a vertical obstacle. So it is easy for the load now to be rolled down. You can just roll the drum down. It will just move easily. You can offload the drum, or you offload the container by just tilting it down the inclined plane. It helps us to move load over a long distance. It also saves time and effort. The energy that you have used in carrying the bulk of the load on your head, or the energy that you have used in pushing it against that resistance on the vertical surface, you can just that energy would be reduced by the inclined plane. It is also efficient. The inclined plane is efficient. It is a simple machine, which is basic and also simple to operate. All right. Uh, Today, I hope that you have learned a lot from what we have said so far.